So let's just look at question 5 then. So the first one is good. It says calculate the energy wasted. Well, if it uses 600 and it produces 450, then the rest of it must be wasted. So you're just going to take them away. So take away 450 from 600, 150. Good. What happens to the energy wasted by the light bulb? So this was actually, it wanted to explain or describe what happened to the energy. That was what went wrong there, okay? I will come back to that one in a moment. Let's just have a look at the next one. Calculate the efficiency. This is a calculation, but we haven't got it quite right. Now, we've got it quite close, though, actually. So we'll come back to, I see what's happened. I'll come back to that in a moment. Next one, it says, calculate the period of time in seconds during which the 600 joules is provided to the 30-watt light bulb. All right, this one's a bit tricky. You have to understand what is watts measuring, and what it's measuring something called power, and you have to understand how power, energy, and time relate to each other. Okay, so that's using the right formula there and understanding that. Okay, so let's just do those few first then. Let's start off with what happens to the wasted energy. So there is going to be some energy was wasted. It lost 150. It's saying, where did that go? Yeah, so the energy that's produced is heat. However, that doesn't fully answer the question, unfortunately, because it still doesn't explain where it went. So, basically, you're right though that the energy transfer would be electrical to light and heat. It is a light bulb, yeah. And it's this one here, which is the wasted energy. So that must have been 150 joules. So where did that heat go? Now we've produced all this heat. Where is it now? Yeah, that's right. It's around the house. It's been spread around. And so what we would use, the word they really love. I mean, you'd probably get the mark if you just said it's produced, it's turned into heat and spread around. You'd probably get the mark then. But the word they really like is dissipated. I'm going to spell it wrong here now, but let's just have a go. I think it's a double S, dissipated. So the energy is dissipated, which just means what you said. It's spread out. It's gone around everywhere. Okay, so that's what that means. So the next one, calculate the efficiency of the light bulb. So what does efficiency mean? Well, it means how well it does what it's trying to do. What was it trying to do? It was trying to turn electrical energy into light energy. It didn't really want to make heat, but it's not 100% efficient. If it was 100% efficient, it wouldn't be making any heat. It would only be making light, and so that would be easy to see. But to work out what the efficiency is, in fact, is you say what proportion or what fraction of the energy that put in was turned into the useful energy. What fraction of it was turned into useful energy? So the useful energy was, so we can write this over here. The useful energy is the 450 joules. And the energy in, or the total energy in, the energy that we put in was 600. So we want to know what proportion of the 600 is that 450. So how would we find that out? So we know if it's going to be, because it's less than 600, it's definitely less than 100%. So the fraction is less than 1, right? So we're going to be doing something which is going to, the answer is going to be less than 1 when we combine these numbers, okay? When we divide something, it's very important to say what you are dividing by what. But you're right, it is divide. So if we did the big number divided by the small number, we would get a number larger than 1. If we do a small number divided by a big number, we would get a number less than 1. So, and you can, if you're ever unsure about this is something you can try out on your calculator, but that is always the case. If you think about it, if I think of a fraction like 3/4, that just means 3 divided by 4, whereas 4 over 3, well, that's 1 1/3, isn't it? That's more than 1. So we're going to divide the small number by the big number we've seen what proportion of the total in was useful. So we do 450 divided by 600. Okay, that should be a 6. Now, you might be able to see in your head at this point what sort of fraction that is. So in any case, I'll say again, sorry? Well, it's not top heavy because it's got a smaller number at the top and a bigger number at the bottom. So, but I mean, in the exam, you'll get given, you're allowed to use a calculator. So we can just do 450 divided by 600, and it is 3/4 or 0.75. Well, that makes sense if you think about it, because you can divide 450 is like 3 lots of 150, and 600 is 4 lots of 150. So the fraction is going to be 3/4 or 0.75. So you can just write, so the answer would just be 0.75, or you can write 75%. Okay, both of those are fine. They usually prefer percentage, but they haven't told you that in this case. So I think either of those will be fine. I would, if to be on the safe side, I'd put percentage. Okay. So part 4 now, it's saying calculate the period of time in seconds during which the 600 watts is provided to the 30-watt light bulb. This is probably the hardest question of the lot, but it's all down to understanding what power is and how it's worked out. Now, power is equal to the amount of how much energy is used per time, how quickly something uses up energy. In other words, if you had a very powerful car and you put some petrol in it, and you just, you put your foot down, then you're going to get through the petrol a lot more quickly than a less powerful car. So it's how quickly you use energy. So it's the energy divided by time. Now, you can use a formula triangle, or you can just rearrange it in a different way. But what I'm going to do is I like people to get away from using formula triangles eventually. So by using the rule of whatever I do to one side, I'm going to do to the other side. It's asking me to calculate the period of time. So what I'm going to do is I'm going to divide by E first on both sides. So if I divide by E, then this E, try that again. This E here would go underneath that. And then you'd let's try that again. So then you'd end up with just 1 over T is equal to P over E. And then what you're allowed to do in these situations, you're allowed to, because you've got two fractions, you can flip them over. So I'm going to turn both fractions upside down. So if I do, I'm going to move the P here. So now I've turned them upside down. Of course, T divided by 1 is just going to be T. So, and that's our answer. So the energy divided by power. Now you can just do that with the formula triangle. It is easier to do it with formula triangles, but I think it's good practice to try to get out of the habit of using formula triangles. But let's just do it with the formula triangle anyway. So it was power is equal to energy divided by time. So time is equal to energy divided by power, which is what I've got there. Okay, so so it's the energy divided by power is equal to time. So 600 divided by 30, which simplifies to 60 divided by 3, which is 20. So the answer is 20 seconds. Okay.